So, again, the manufacturing process, I'm making some rotors and they've got a certain eccentricity about them, okay, and they've got a following distribution. So I've got between 0 and 5 millimeters, I've got this function is my probability distribution function, okay. So it looks, I mean, if I was to draw it, it's kx squared, so it's obviously a parabola. Let's see whether this is working. So if this is x, this is my p of x, I'm looking at something that looks like that, okay? Between 0 and 5. So if that's 5 and that's 0, then this is my probability distribution function. And the limit of that, basically the integral of this between 0 and 5 is going to be 1. Okay, so the chance of me making a rotor with an eccentricity between 0 and 5 is 100%. Okay, there'll always be. And that could be due to the limit of the machine or something like that, that I can't make it more than 5 millimeters out of zinc. K is a constant that will determine, first off, we've got to find A. We have to find the mean, the standard deviation, and the mean square value of the eccentricity, and B, the probability of realizing that x is less than or equal to 2 millimeters. And so we can go through the process to find the mean. So first off, we need to find k, okay, because we need to work out these values. And so we know that p of x dx, the integral between minus infinity and infinity, is equal to 1, okay. Obviously, we don't need to go from minus infinity to infinity because we know that our limits of our integration are 0 and 5, so we can use them as our limits. We stick in our function p of x, kx squared, dx, obviously that we know must equal 1. And so if you multiply it out, if you take this integration, you get k times x cubed upon 3, which is here. Between 0 and 5, obviously 0 in here is 0, okay? So we've got k times by 5 cubed, okay, which is 125 divided by 3 equals 1. If you rearrange it solving for k, you get 3 divided by 125 is equal to k. So we've got a value for k. To find the mean, you stick in x into this integral, okay? So this is the mean value. You've got your x, px in here. So again, we stick in, we've got x times by k x squared, which is our px term. So obviously the k is a constant, that come outside. You've got x cubed in here, you integrate x cubed, you get x to the power of 4 divided by 4 between 0 and 5. And so you stick in, obviously 0 in here is 0. 5 to the power of 4 is 625. And you multiply that by k, you get 3.75 millimeters. Okay, so the mean value of that distribution that I drew, okay, is that parabola, okay, is going to be 3.75 millimeters. So my parts, yeah, if I, like I said, if I took a certain number of parts and I measured them and I added all those measurements divided by the number of samples, I'll get 3.75. Okay. But this is the way of doing it using integration. I didn't need to sit and measure it. I knew the distribution, and so I can integrate that and I get the result. That means to get the standard deviation, I need to follow this process. I know that we've got the standard deviation is the mean square, okay, minus the mean squared. Okay, so to get the mean square, I put x squared into this integral. Okay, again, k will come outside. Okay, and I end up with x squared times by x squared in here, which is x to the power of 4. Obviously, this becomes x to the power of 5 divided by 5, between 0 and 5. You go through and measure it. 5 cubed, so 5 to the power of 5 is 3,125. Multiply that by k, divide by 5 over here. And then obviously I minus my mean value squared, and I get 0.9375. And to get the standard deviation, we can see that you take the square root of that and you get 0.9682 millimeters. So my standard deviation is almost 1 millimeter. Okay. And obviously the mean square, I just use that process that I used here. So it's just this side, it's this process to get this term. So it's this bit, this bit, this bit, and this bit. Okay. And if I do that, I get 15 millimeters squared. And the RMS will obviously be the square root of 15. Now, to work out the probability that my eccentricity is going to be less than 2, okay, instead of integrating between 0 and 5, okay, we know that that equals, if I integrate this between 0 and 5, I get 1. Yeah? But obviously, if I'm looking for the probability that that eccentricity is less than 2, I integrate between 0 and 2. And so instead of having 0 and 5 here and 0 and 5 here, I've got 0 and 2. So I integrate between 0 and 2. 2 cubed is 8. Okay, so I get 8 divided by 3, multiplied by 3 over 125. So that becomes 8 divided by 125, which is 6.4%. So the chance of me getting, so let's say that my variation gives me up to 5 millimeters of eccentricity, but what is acceptable in terms of a manufacturing process is 2 millimeters of eccentricity. Then I know that if I run my manufacturing process, I'm only going to get that part 6.4% of the time. So I need to do something about my manufacturing process, quite obviously. Okay.